Hi everyone. So this time let us discuss about the measures of central tendency for ungrouped data. So at the end of this lesson, you must be able to describe the measures of central tendency and compute or obtain the different measures of central tendency. So let us first define central tendency. Central tendency is a statistical measure that determines a single value that accurately describes the center of the distribution and represents the entire distribution of scores. The goal of central tendency is to identify the single value that is the best representative for the entire set of data. So one of these is averaging. Let's see. So by identifying the average score, central tendency allows the researchers to summarize or condense a large set of data into a single value. Thus, central tendency serves as a descriptive statistic because it allows researchers to describe or present a set of data in a very simplified or concise form. In addition, it is possible to compare two or more sets of data by simply comparing the average score for one set versus the average score for another set. So we have three measures of central tendency. We have the mean, median, and mode. So these are the symbols for mean, median, and mode. So when we say mean, it is the most commonly used measure of central tendency. Computation of the mean requires scores that are numerical values measured on an interval or ratio scale. The mean is obtained by computing the sum or total for the entire set of scores, then dividing this sum by the number of scores. Or in other words, this is the average of the scores. Conceptually, the mean can also be defined as the amount that each individual receives when the total or the summation of x is divided equally among all n individuals or the population. The mean is the balance point of the distribution because the sum of the distances below the mean is exactly equal to the sum of the distances above the mean. That is why the mean is the most preferably used measure of central tendency because it is a non-biased and fair. Changing the mean. In the first bullet, because the calculation of the mean involves every score in the distribution, changing the value of any score will change the value of the mean. Therefore, there is a relationship between the mean and every score in the distribution. So if one score changes, the mean will also change. Modifying a distribution by discarding scores or by adding new scores will usually change the value of the mean. So if we remove one score from the distribution or number of scores in the distribution, or if we added new scores in the distribution, the value of the mean will also change. So to determine how the mean will be affected for any specific situation, you must consider how the number of scores is affected and how the sum of the scores is affected. So in finding the mean of a data, we have the formula. Mean is equal to the summation of x all over n, where n is our sample, or mean is equal to the summation of fx all over n if frequency in the table is present. So to further understand, let us have an example. Find the mean score of the following sample data set. So we have the quiz scores 1, 5, 7, 7, 6, 8, 10, 9, 5, 10, and 8. So using the formula, mean is equal to the summation of x all over n. So we will sum up all the quiz scores, and that is equal to 76, where n is equal to the number of scores. So we have 11 scores in our sample data set. So that is 76 over 11, or that is equal to 6.9090 or approximately 6.91. And that is now our mean. And 6.91 can represent the whole data. So that is the average of the whole data. Next, in example 2, find the mean score of the following sample data set. So we have the age and frequency. So this time, frequency is present. So we will use the second formula. So we have the following age: 15, 16, 17, and 18. And their frequency, the frequency of 15 is 7. The frequency of 16 is 12. The frequency of 17 is 14. And the frequency of 18 is 7. So in our formula, we have to get the summation of fx. That is why we have to create another column for fx. The column for our fx means that we have to multiply x by f, or the age by frequency. So 15 times 7, that is 105. 16 times 12, that is 192. 17 times 14, that is 238. And 18 times 7, that is 126. So now we will get the summation of fx, or the total of the number in the column of fx, and that is equal to 661. Since we already have what we need in our formula, let us now find the mean. Using the formula, summation of fx over n, that is 661 all over 40, because our sample is 40, or that is the total frequency of the distribution. So 661 all over 40 is equal to 16.53, and that is now our mean age. Next, we have the median. So if the scores in a distribution are listed in order from smallest to largest, the median is defined as the midpoint of the list. So this is the value which separates the largest 50% of data values from the lowest 50%. Computation of the median requires scores that can be placed in rank order, that is smallest to largest, and are measured on an ordinal, interval, or ratio scale. Usually, the median can be found by a simple counting procedure. So we have 1. With an odd number of scores, list the values in order, and the median is in the middle score in the list. Number 2. With an even number of scores, list the values in order, and the median is halfway between the middle two scores. So let us have an example to further understand. So in this example, find the median of the following set of data. We have 35, 47, 36, 24, 55, 32, 29, 57, and 32. So the first step is to arrange the observation in ascending order, or from smallest to largest. So in the data set, 24 is the smallest and 57 is the largest. So since the number of observation in our set of data is 9, and we know that that is an odd number, we will use the formula n plus 1 all over 2. So that is 9 plus 1 all over 2, which is 10 divided by 2, and that is equal to 5, or we will get the fifth observation in our set of data, and that is 35. So our median is 35. So in our next example, still we will find the median of the set of data. So again, after arranging the observations in our set of data, we will get the number of observations. And since our set of data has 10 observations, and we know that that is an even number, we will find n over 2 and n over 2 plus 1, wherein n is equal to our number of observations. So that is 10 all over 2, and that is equal to 5. So we will get the fifth observation, and then n all over 2 plus 1, or that is 10 divided by 2 plus 1, and that is equal to 6. So we will also get the sixth observation. And in our set of data, that is 35 and 36. After that, we must get the half of their sum. So 35 plus 36, that is 71, and the half of 71 is 35.5. And that is now our median. In our next example, let us find the median score of the following sample data set. So we have the age 15, 16, 17, and 18, and the frequency of the age 7, 12, 14, and 7. So in finding the median score of this dataset, we must find first its cumulative frequency, because we will be needing that in finding the median of a sample dataset wherein frequency is present. So in getting the cumulative frequency of the dataset, first we must copy the first frequency, and that is 7, and following the arrow, we will add 12, so that is equal to 19. And again, following the arrow, we will add 14 to 19, and that is equal to 33. And then following again the arrow, we will add 7 in 33, and that is equal to 40. And the last number of our cumulative frequency must always be equal to n, which is 40 in our example. The cumulative frequency is the order of frequency of our age. In getting the median of sample dataset, we will get the half of 40, and that is 20. And because 40 is an even number, we will also get the 21st term of the dataset. So in cumulative frequency, that is 7, 19, 33, and 40. And the 20th and the 21st term is included in 33. And since the age that is present in that cumulative frequency is 17, so we will consider that as our 20th and 21st term in our dataset. We will add the two terms, that is 17 plus 17, divided by 2, and that is equal to 17. So meaning our median in our dataset is 17. So one of the advantage of the median is that it is relatively unaffected by extreme scores. Meaning, though we have a very low score or a very high score, still median is not affected as long as it is the middlemost score in our dataset. Thus, the median tends to stay in the center of the distribution even when there are a few extreme scores or when the distribution is very skewed. Ibig sabihin, kahit magkakalayo o magkakalapit yung scores, as long as the median is at the center, it will not change. So in this situation, the median serves as a good alternative to the mean. So lastly, we have the mode. So the mode is defined as the most frequently occurring category or score in the distribution. The mode can be determined for data measured on any scale of measurement. That can be nominal, ordinal, interval, or ratio. The primary value of the mode is that it is the only measure of central tendency that can be used for data measured on a nominal scale. Let us have an example. What is the mode of the following sample data? So we have observations of 35, 47, 36, 24, 55, 32, 29, 57, 32, and 40. So in finding the mode, for ungroup data, it is not necessarily that we are going to arrange the data in ascending order or descending order. Because based from the definition, we are just going to spot the most or frequently occurring observation in our data set. So in this sample data, the most occurring number here is 32. So our mode is equal to 32. In our next example, what is the mode of the following sample data? Here we have the table for age and frequency. So in finding the mode given the frequency, we are just going to spot the age with largest frequency. And since in our frequency, 14 is the largest number, meaning 17 occurred frequently in our sample data. So 17 is our mode. So because the mean, the median, and the mode are all measuring central tendency, the three measures are often systematically related to each other. So in a normal distribution, the mean, median, and mode will always be equal. So we have the properties of mean, median, and mode. So the mean is the most commonly used measure of central tendency. One drawback of the mean is that it is heavily influenced by a few very high or very low data values. In these cases, it is more common to use the median. So if there are very high or very low data values, it is more preferably to use median. Third, the median is unique but cannot be found for categorical data or for open-ended frequency distribution. Next, the median does not use all the values, so it is less affected than the mean by a few or small data. The median is unique and can be found for open-ended frequency distribution. Lastly, the mode has the advantage that it can be used to measure nominal data, but it is not unique. There may be more than one mode or none at all. So that is all for the measures of central tendency.